Today's topic is from class 12th chapter determinant, because in previous video we discussed about the definitions and solution of determinants. Already we have to done, and now today we start there are two topic here we include. One is minors and cofactor, and other is properties of determinants. So first we discuss about the minors and cofactors. So here we define what do you mean by the minor and what do you mean by the cofactors. So definition of minors, let A equal to Aij be a square matrix of order n, and it is denoted by Mij. I means row and J means column. The minor Mij is the determinant of a square submatrix of order n minus 1 obtained by leaving ith row and jth column. Means it is simply value you find out with the help of submatrix and also in form of the determinants. Their place value is very important because Mij. Here I represent means row and J represents a column. So here we illustrate the definition with the help of examples, because example is very easy going and very easy understandable ki how you find out the minus of the given matrix. Because first condition is what? Any matrix is square matrix, because in definition here we write down, and chapter determinant also have the definition is only you find out determinant when given matrix is square matrix. So here we have the example of 2 by 2 matrix, it is square matrix, and now you find out the minus of this matrix. So here we represent minus means Mij. So here we find out M11. 11 means first row and first columns you leaving out, because definition is obtained by leaving the ith row and jth column. So 1 it means you leaving first row and first column. So what is remaining? Remaining is 7. So 7 is the answer. Similarly, M12. 12 means first row and second column. So your value is 5. So you write down here 5. And then M21. Now I think easy going here. 21 means second row and first column. Second row and first column means you have 3. So you write down 3 here. Similarly, M22. 22 means second row, second column. So second row and second column, then your value is 2. So you write down 2 here. So these are the minors of the given matrix 2 by 2. Okay, then this is very easy example because we discussed about the 2 by 2 matrix. So there is no lengthy part, only you leaving the row and column you got the answer directly, because there is no solution here. You got the direct answer because your matrix is in order of 2 by 2. But here we discuss about the 3 by 3. Suppose your matrix of order 3 by 3, then how you find the minus of this matrix? Procedure is same again. The 1 it means here we find 1 1 means first row and first column is important. You leaving the first row and first column, then rest value you write down in form of the determinant, because you write down here sum matrix. Sum matrix means this order is sum matrix here, and n minus on this one also here we write down. So your order is 3. So n minus means your order is 2 by 2. So rest value is 4 1 5 2. Okay, then you solve this determinant, and then 4 into 2 minus 5 into 1. So 4 2s are 8 minus 5. Your answer is 3. Okay, so if matrix order is greater than 2 by 2, then you have 3 by 3. Like 4 by 4 is also very lengthy. And then now you find out all minors, because this is the single value of this matrix. So you find out M12. Again very easy, because already we know the how you solve the determinant. M12. 12 means first row and second column. Then 2 3 1 2. So you write down here 2 3 1 2. Similarly, you find out 2 into 2 minus 3 into 1. So your answer is 4 minus 3. Answer is 1. Similarly, you find out M13. M13 means first row and third column. First row and third column means 2, 4, 3, 5. So you write down here 2, 4, 3, 5. Then 2 into 5 minus 3 into 4. So 2 5s are 10 minus 3 4s are 12. Your answer is minus 2. Similarly, you find out M21. M21 means second row, first column. Second row, first column means this is second row, and now you ignore this first column. So what is remaining? 0 6 5 2. 0 6 5 2. So answer is 0 into 2 minus 5 into 6. So answer is minus 30. Okay, then similarly you find out for M22. M22 means second row, second column. Then your value is 1632. Okay, so you write down here 1 into 2 minus 3 into 6. Answer is 2 minus 18, that is minus 16. Similarly, M23. M23. So you find out second row of third column 1035. So you write down here 10 and 35. So 1035 means 5 minus 0. You have 5. So you find out all the minus. Here we find out only 1, 2, 3, 4, 5 and 6. And then we find out 3, 1. M31. So M31 means third row and first column. If you find out third row and first column, then this is third row and first column. So 0641. So you write down here 0641. So your answer is 0 minus 24. Answer is minus 24. Similarly, M32. So M32 means third row and second column. Third row and second column 1, 2, 6, 1. So you write down here 1, 2, 6, 1. Then answer is 1 into 1 minus 2 into 6. 1 minus 12 is minus 11. Similarly, you find out 3, 3. Third row, third column. Third row, third column 1024. 1024. So answer is 1 into 4 minus 2 into 0. That is 4. So their finding solution is very easy because you operate according to their definitions. Definition is very important. Minor, it means you find out the place value, like you have 1 1. It means first you leaving the first row and first column. Rest value is your answer. Similarly, according to order of 2 by 2 or 3 by 3, you taking as a 2 by 2. 2 by 2 is very easy going because direct you select the value. But in 3 by 3 you first simplify because your rest value in form of 2 by 2 determinant. Then you simplify the determinant, you got the answer. This is the same way you find out the cofactors, because minus and cofactor, the one difference between them only, sign difference is very important. So here we define the concept of cofactor. So first, the definition is same for both. Cofactor is denoted by Cij only and minus is defined by Mij. What is the difference? Difference is Cij is equal to minus 1 to the power I plus j Mij. Means here we find out minors and then we find out the cofactors. So definition is same, only sign difference is here. Place value is important because you find out like C11. So C11 means first you put minus 1 to the power 1 plus 1 because of your value of row is 1, value of column is 1. So your addition of row and column, if their sum is even, then your answer is positive. If your sum is odd, then your answer is negative. So here minus 1 to the power 1 plus 1, it means you have a power is even. So your answer is positive. So you write down M11. It means you directly write down M11. So what is M11? First row and first column. It means your answer is 2. So C11 is same according to M11. And now you write down C12. So minus 1 to the power 1 plus 2 M12. Now 1 plus 2 is 3 and 3 is an odd number. Odd number means your answer is negative. So you put minus sign here. So minus M12 means minus M12 means first row and second column. So answer is 0. So 0 there is no difference because minus sign 0 not affected. So you put answer 0 as it is. And now 2 1. 2 1 means minus 1 to the power 2 plus 1 is M21. So there is no change. Again you have the odd value because 2 plus 1 is again 3. 3 is an odd number. So your answer again in form of negative and write down 2 1. So 2 1 means you write down second row and first column. So your value is 3. But answer is minus 3 because before of this you put this formula. And now last value is 2 2. Similarly minus 1 to the power 2 plus 2 and then you write down M22. So answer is directly M22 because there is no effect here because their sum is even and sum is even, it means positive sign you obtain there. So you write down directly M22, it means second row and first column you ignore it like this. What is the value of this? You write down 3 here. Here minus 1, sorry. Here you put minus 1. So, this is very easy going. If we summarize the concept of minus and cofactor, so one major difference between them, minus sign is very affected. You put the value, their place value is important. If their place value sum is even, then you write down directly the answer of minus. If sum of place value their sum is odd, then you put minus of before minus. So you maybe write down directly without any this particular formula, because if we solve the determinant, then I also explained that this is very important how you put here minus sign and plus sign. So place value is important because first value we take positive there, second value we take negative, and third value we take again positive. Because their place value is 1 1, 1 1 means 1 plus 1 is even, therefore you put plus sign. Second value is 1 2, it means 1 plus 2 is 3 and 3 is odd number. So odd number having the minus sign, so you put minus sign there. And similarly 2 1 3, 1 3 is again even, even means you put positive sign there. So therefore, so we put the solution of the determinant. First value is a positive, second value is a negative, and third value again we put the positive because depend on the place value. So now here we take the another example, like you have here only 2 by 2 example. Now here we consider example second, but now here we consider 3 by 3. Suppose you have the 3 by 3 determinant, and then how you find the cofactors. So similar concept you apply here. Now for example we write down here C11, so you put plus sign because now directly without formula how you write down. Here we write down minus 1 to the power 1 plus 1 for the explanation only, how you put plus sign, how you put minus sign according to this concept. But now we know the concept from the previous formula, so we write down directly. Only here we count the place value. 1 1 means 1 plus 1, their sum is even, so you put plus sign here. If 1 2, then we have minus, so minus you put here. And now concept is same. 1 1 means you leaving the first row and the first column. So rest value write down here in form of the determinant. So determinant is very easy. So you put 2 to the 4 minus 1 is 3. So now you write down the direct answer. Similarly, you write down C12. 1 2 means you put minus sign. Why you put minus sign? Because of their sum 1 2. 1 plus 2 is 3 and 3 is the odd number. So we put minus sign here. Now we find the concept is same. You are leaving first row and second column. So your answer is 0 1 and 1 2. So answer is minus of minus 1 means answer is 1. Okay, then similarly you find out for C13. C13 again you have the positive sign because 1 3. 1 plus 3 is 4 and 4 is a even number. So you put plus sign before of this. And now 1 3 means you are leaving first row and third column. So you have 0 2 and 1 1, and then your answer is 0 minus 2, answer is minus 2. So process is same, and now you find out for C21. 21 is again have the meaning same. 2 plus 1 is 3 and 3 is an odd number, so you put minus sign and then write down the value. What do you mean by 21? 21 means you are leaving second row and first column. So what is the answer? 1 2 1 2. You write down here 1 2 1 2. Okay, then answer is 0. So there is no meaning of minus sign here. You put 0 directly, it means answer is 0. And then C22. Okay, again 22 means you put plus sign. Plus sign means their sum of place value is 2 plus 2 is even, because 4 is even. And now what is the value of 22? 22 means second row and second column. So corner value write down 3 2 1 2. So you write down here 3 2 1 2. And the solution is 3 into 2 minus 1 into 2. So 3 to the 6, 6 minus 2 is 4. And then C2 3. You put minus sign. Why you put minus sign? Because 2 3. 2 plus 3 is 5 and 5 is an odd number. So you put minus sign here. And now what do you mean by 2 3? You leaving second row and third column. So value is 3 1 1 1. So you write down 3 1 1 1. So minus of this 3 minus 1, answer is minus 2. Okay, so this is the process is same. In the same way you find out for C31, C32 and C33. But one major difference you take here, you find out the cofactor, then cofactor having the place value is very important. In minus there is no importance of the place. You find out M11, that is not required for the sign, you put plus or minus. But in cofactors, their place value is important. We write down the formula Cij equal to minus 1 to the power I plus j and then Mij. So concept you taking up from the formula and then directly use the concept. If concept is what, only you count the place value is even, only you count the place value is odd, then very easy going, you find out the cofactors, you find out the minors. In cofactor you remember for a sign only, if their place value is odd you put minus up before this, and then their sum of place value is even, then there is no change in the answer, you put as it is. So I think both topic is clear, how you find the minors, how you find the cofactors, because in earlier we also discussed about the solution of determinant, and we also know the how you find the 2 by 2 determinant and 3 by 3 determinants. So now let's start properties of determinant. Properties of determinant. Properties of determinant. Here you start property 1, property 2 and then so on, and then explain one by one okay, how property you use and how it is applicable for the given determinants. So first property is the value of the determinant remains unchanged if its row and columns are interchanged. It means your given matrix, if their rows they are complete converted into the column, then there is no effect on answer. Suppose your given matrix is A, B, C, X, Y, Z, U, V, W. Okay, and then after solution of this determinant, you got answer is capital X, suppose, and then interchange row and column. So your determinant is now ABC is first row, so ABC is first column. Second row is XYZ, so second column is XYZ. Third row UVW, so third column. Then again you solve this determinant, your answer will be X. So if you change the row into the columns or column into the rows, then there is no effect on the answer. Answer will be same. Okay, then second property, if any two rows or columns of determinant are interchanged, then sign of determinant changes only. Okay, you want to change first row with the third row, or first row with the second row, first column with the second column or second column with the third column, then all answer is affected by the sign only. For example, suppose you write down here like A, you write down like similarly A1, B1, C1, A2, B2, C2, A3, B3 and C3. Okay, then now here we interchange like R1 interchange by R3. Okay, you use the sign of interchange both the side arrow. If you want to change row with row, then this symbol you use R1 interchange by R3, and that is the compulsory part. You change row only row and column only with column, not row and column they are interchanged. Like R1 you change by the C1, that is not possible. All columns you converted like in the first property, that is possible, but single row is not interchanged by the single column. So here you interchange R1 with R3, and now again your answer is X, and then after changing row to row, so here A3, B3 and C3, R2 no change, you put as it is, and now your R1 in the third row, that is A1, B1 and C1. So answer is only minus X. It means you solve the first determinant directly without any confusion, then your answer is X. But you want to change, if it is easy going, if you convert first row with third, then answer is affected by the sign only, it is in minus. So this is the changing of R1 with R3. Now here we suppose you write down C1 interchange by C2, and then your determinant is like you write down same. So your column is B1, B2, B3 in the second. So second is the first and first is the second. So you write down here B1, B2 and B3. Similarly you write down here A1, A2 and A3. C1 there is no change, you put as it is, and the answer is again minus X. So you convert your column with column, any other column, then the answer is affected by the sign only. So now we discuss about the third property. Third property is if any two rows or columns of determinant are identical. Identical, it means your corresponding elements are same, and then the value of the determinant is 0. Means there is no solution you find out, you put directly their value is 0. So for example, suppose here we write down, suppose determinant of this value, you write down the x, y, z here and ABC, and you also write down here ABC. Okay, then now your R2 and R3 both are the same element, R2 having ABC, R3 also having ABC. It means R2 and R3 are identical. Okay, after this property you write down the answer is 0. Without any solving you write down this particular property. And how is it possible? You take the example like same here, suppose you simplify, and here we take example of 2, 3, 1, and here we write down 2, 4, 2, similarly 2, 4, 2, and then solve the determinant. 2 of 4 to the 8 minus 8 minus 3, 2 to the 4 minus 4 plus 1, again 8 minus 8. So there is no change. 2 of 0 minus 3 of 0 and plus 1 of 0. So answer is 0. So you simplify also with the help of numeric examples. If two rows are same, two rows are identical, then your answer will be directly write down 0. Like same condition we write down for the row wise row, and we write down column wise column. The property is same. If two columns are also identical, then answer you will put 0 there directly without any solving. But before of this you write down the property of this. By this property your answer will be 0. Okay, and then the fourth property, if Each element of a row column of a determinant is multiplied by a constant k, then its value gets multiplied by k. It means any particular constant term or scalar term you multiply inside a particular row or particular columns. Otherwise, you directly put that value and then find the determinant that is the same value. You multiply only the k direct in the answer, or you multiply in the row or columns, then answer will be same. Answer will be not affected. So by this property here we take the example like you write down value of determinant here, suppose like k, and your value is ABC. Similarly you write down here XYZ and you write down here UVW, okay, which is equal to no change of this value. You write down AK, BK and CK. After this you write down XYZ, you put as it is, you write down UVW as it is. Answer suppose K into X, and this is equal to suppose capital X, and you got directly capital X. So both answers are same. You multiply directly the constant term, or you multiply inside a row or inside a column, then after you simplify the determinant, their value and here this value both are same, or before after multiply or inside multiply value of column and rows. And then we explain fifth property. Property 5. Now we discussed the fourth property already, we have done. Now fifth property, the statement is if some or all element of row or columns of determinant are expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. It means, suppose you have a square matrix is given like in the form of determinant. Here we write down, suppose you have a determinant, your value is x plus a, y plus b and z plus c. Okay, and now here you write down u, v, w and p, q, r. Okay, then your first row is x plus a, y plus b and z plus c, because here we write down any two values you write down in form of sum or difference is given in the first row, in the first column maybe is here, and then this determinant you express in form of like first value with x, u and p, y, v and q, z, w and r, and some plus sign is here, you put plus sign, and then you write down the second value. Second value is a, so you write down a here, u and b. Similarly b, v and q, and then c, w and r. So you convert into the form of two determinants separately. If one row or one column given values, they are in form of the sum, there are two sums, they are added, and now you express the determinant in form of the two. Suppose there are two rows are in form of the addition, then again you separate out this two and this two. So there are four determinants you convert. Like this operation is given in row wise. Taking the example of the different, like you have a equal to, suppose here you have a1 plus a2, b1 plus b2 and c1 plus c2, and now you have here c1, c2, c3, d1, d2 and d3. So this also you can express in form of the addition. Now you have the first value like a1, b1, c1 in the first determinant, so you put as it is a1, b1 and c1, and then second column you put as it is c1, c2 and c3. Third column again you put as it is, there is no change, and now you have the sign sum here, so you put plus sign, and then second value is what, a2, b2, c2, that is your first column, a2, b2 and c2. Now you write down the second column as it is, no change in the second column because single value is given there, and then d1, d2, d3. So that is very easy. If you have the two values, their sum is given in the first row, or you have two values, their sum given in the first column, maybe second column, maybe third column, but their expression is same. You convert into the first determinant plus the second determinant. Not compulsory if this given value in the first column, then it is possible. If this sum value is given in the second column, then also you can express in form of the two determinant. This value given in the third column, then also you can be expressed in the form of two sum of two determinant. Similar process you apply for the same. R1 is given in form of two addition, or R2 is given, or R3 is given. Then that is the same apply, same procedure you can convert into the two determinants. So this property now very easy going. If there some value is given, then you express in form of the two. Now here we study about the sixth property. If to each element of any row or column of a determinant, the equimultiple of corresponding elements of other row or column are added, then the value of the determinant remains same if we apply the operation. Means Ri equal to Ri plus k times of Rj, and now you write down here Ci is equal to Ci plus Kj. So here we write down like example, because this is the statement, and this statement how it is applicable in the given form of the given matrix. Like suppose here we have the example, very easy. You write down in the first determinant you write down. So first row is ABC, second row is XYZ, and third is PQR, right? So now you apply the operation. Here we apply this row wise operation. So here we write down R1 tends to, because you operate R1, not you write down equal to, R1 tends to means you change R1 with respect to any row. So your R1 you put as it is, plus like you write down 4 times of R3. Okay, your operation is what? You want to change R1, and R1 you operate with respect to R3, some constant or some scalar terms you multiply in R3 and then you add with R1. So what the changes are here? So you can write down R1 means you write down A and then plus sign 4 times of R3 means 4 here, so 4P. Similarly, same operation here, you write down B plus 4Q, and then you operate here C plus 4R, and then there is no change in R2, so you put as it is this term, and then PQR also you put as it is. So there is no change in the operations. Now, but this operation you can convert in form of this fifth using fifth property. So this determinant you can express in form of 2 using fifth property. So your answer is, now first value is A, and then X, then P, and similarly B, Y, Q, and here C, Z, R, plus second value is 4P, 4Q, and here 4R, and then X, Y, Z, and P, Q, R. Okay, so now we have that the last, we discussed the last 7th property, but before of this, first we explain this property. Okay, now it is very easy going. Now you can express in form of the two determinants. So first determinant you put as it is, because that is your actual given part of determinant. So you write down directly the answer is determinant of A, and now you put plus sign here. 4 is common because 4 having all having the first row. So rest of the value you put as it is P, Q, R, and then X, Y, Z, and then P, Q, R. Okay, because 4 is common. In determinant you taking particular any constant multiplier, any scalar values, they are common in row wise or column wise, you taking outside. So you taking 4 as the outside because this common value in R1, so you taking outside. Now here we have your R1 and R3, both have the corresponding elements are same, it means they are identical. So you write down the property here, R1 and R3 are identical. And what do you mean by the identical? Their answer is 0. So there is no change if you operate any particular row with any particular constant or scalar term with the other rows. You operate of any row wise operation or column wise operations, there is no effect on the given determinant. Means value of this determinant is, your answer is, suppose determinant of A you put as it is, and after operation you again calculate this value, so there is no change in the operations, you have the same value. So this property is also very useful. Now here we discuss two more properties. Yes, now we have the seventh property, like this is the second last property. Let A be the square matrix of order n and such that each element in a row or column of any matrix A is 0, then the value of the determinant you find out overall is 0. For example, like here we explain, because this property is very easy. You consider, like suppose you have any determinant, like first row having all 0, second row having element, third row you having element, and now you want to find their determinant, and then because first row having all elements 0, so answer is 0 without any solving. Maybe another example, like you have find out suppose ABC in the first column, 0, 0, 0 in the second column, or you write down XYZ, then ultimately again you put the 0. So means there is a particular one thing is important. If any one row having all elements are 0, or any one column having all elements are 0, that is not dependency first column or maybe first row 0, depend on the which column having all elements are 0. Ultimately you, without finding, you write down 0 there according to property. Maybe after simplify you check out if it is possible. Okay, and then that property is a formula you use. Suppose you have two matrices like A and B. If you multiply and then find their determinant, or otherwise you find separately their determinant, you use this formula and verify the question. Okay. One more another formula you use in like the same you use as a property. You have particular matrix or determinant, you find out their cofactors, and determinant of cofactor which is equal to determinant of given matrix of n minus 1. Here n is the order. Suppose like you have 2 by 2 matrix, then their formula determinant of A and order is 2, so 2 minus 1, it means determinant of A itself their answer with respect to the cofactors. So these are all properties are very easy. Okay, that is very easy in operations, because next we going on the suppose different variety of the questions is given in the determinant, and then we use this all property and that type of questions, and then our answers are very easy in getting answer very easy, because some proved questions, some stored questions are there. So with the help of this property you do the question, then your question is very in easy format. I think all the properties you got it. So I summarize today's my topic. My topic is like minus and cofactor, and now here we discuss properties of determinants. Both are very in easy way you can solve the given problems. If you find out minus, if you find out cofactors, are you using the condition of property. Okay, and then next video we have the questions, they are related with the properties of determinant, and one more topic is their area of triangles. So in next video we discuss depend on all questions, they are depend on the properties, and one more topic, area of triangle. Thank you.